Puneet, we are live.
Okay. Good evening, everyone, and welcome to yet another webinar from Math Revolution. And thank you so much for providing this opportunity. Our heartily thanks to GMAT Club and all the complete team. We have been conducting a lot of webinars these days, and we have been talking a lot about the non-math skills, the non-math background students, the comprehensive approach towards the studies for GMAT, DS, which is especially one of the tricky section, and how do we solve the DS questions using variable approach, which is one of the unique approach from Math Revolution. Today's webinar is quite different. It's all aligned with PS. So how are we solving the PS questions using IV approach, which is one of the another approach technically devised by Math Revolution founder Max Lee. And as the topic says, how to effectively solve. So that word effectively itself has two words into it. So first is time saving and second is accuracy. So keep yourself ready for this ride today. Keep your pen paper ready, and I'm connected to you over the chat as well. So if you have any questions, please just let me know. I'll ask. I'll try my best to answer all the possible questions. And yeah, let's start with this. So our agendas talk about, we'll be talking about the IV approach. What exactly is IV approach, and where does it start from? How does it look like? And what is it that is the PS questions all about? How do they look like? Everyone generally knows about it that there would be five options to the questions, and it is pretty easy to, solve a question and then mark answer out of it. So that is wherein we start with. Secondly, then when we talk about the meaning of the IV approach, the name has been taken to from the Ivy League colleges. Those are the leading college for the master's program, not only for the master's but a lot of other programs as well. And this particular approach can get you higher score of Q48, 49, and Q50 even. So your applications to this particular degree programs and your universities, Ivy Leagues, is much easier to get through. This is something I just want to brief about, like what are we discussing today. There are a couple of jargons that we use into it, so I just don't want you to get confused with it. So I'll be talking about some axioms. So axioms are like some algebraic forms which are devised so that they can be applied. I'll be talking about how to solve a question by taking an LCM or attaching 100 or initials. Then there would be a couple of discussion on each together questions, which is majorly the questions based on mixtures. And then I'll be talking about how do we devise or form a complementary 2 by 2 table. What is it? How is it different from separated 2 by 2 table? And we'll be talking about local ratios. So every concept that I go through has a question to it, so that therein where we will able to see the applications as well. Before going ahead, reason behind I'm taking this webinar on PS today is very simple. Uh, I've been connecting with a lot of students across the globe these days through the free consultation call that Math Revolution is providing. The link for which is available on our website, which is www.mathrevolution.com. And it is also available on GMAT Club. So you can definitely book your call if you need to specifically talk to me and discuss about your preparation for GMAT, Quant, and how to raise the score, where to start from, and all the questions would be answered. So, whatever summer, if I have to summarize every call that I've taken more than 150 calls over a month. So what I've got to know is, like, PS is not that difficult, but students makes it difficult at the end, and then they get trapped. So many a times they over assume things, they do unwanted calculations which is not required. They start solving through the conventional approach, and therein where they lack time, and at the end it's all messed up. So we'll be talking all those things today, so that it becomes easier for you to tackle time. The most important thing in GMAT is time. If you're able to save those amount of minutes for yourself in solving a question through any quick approaches like variable and IV, your journey is very easy because you'll be able to focus. And yeah, that is it. So let's go ahead with this. So IV approach, It is applied to various type of PS questions, and it's question to equation conversion. So whenever we get a question in terms of words, we can easily convert that into algebraic expression. So that becomes much easier for us. Then question is solved very quickly and more effectively. You get more time to solve the highest difficulty questions, and it provides much accuracy to yourself. So what happens is, like, if you have such kind of weapons with you therein where you could get quick answers for certain questions, you will be able to focus more on the difficult level questions. And in that scenario, you will not be missing on to any possible consideration that has to be taken, especially into DS questions. And you can double check your questions, when you're using the variable approach that is all together for the DS. And so that is something which we have covered a lot ago. So you could always visit to, you can go back to all these webinars or videos on YouTube on the GMAT Club, and the more you share among yourself, it becomes much easier for everyone to look over it. So anytime you are liking the approach today, you have questions, you can put into the comments. If you're not liking anything, you can definitely dislike it. That's not a problem, because that gives us understanding that we still have to raise it to the bar where students would like it, because this is everything, it's for the students. Going ahead with the same, I need to talk about the characteristics of the IV approach first, after having spoken about the roles. So it's a very much logical and pattern oriented. So once we start solving it, these are the initial slides that we are going through. Once you are sailing through the concepts, that then you will understand that they're very much logically aligned, and but you can definitely understand a pattern which is oriented. It can detect the errors very quickly. And if at the very first step you're making some error, you can definitely make a note of it and you can stop solving it in that manner. Or it can definitely minimize the errors as well. If you are able to convert the word problems into mathematical expressions, there has been instances wherein a small negative sign can make a huge difference. So your equations has to be properly formed through these axioms that we will learn today and talk about. And then definitely the equations answered has to be done correctly. It saves time. This is what I'll repeat myself many a times during this webinar. It saves time and it increases the accuracy. If your time is saved, your accuracy is always maintained and consistent, and so does your scores are more efficient. So that is the major characteristics of the IV approach that we talk about. And I'll start with the introduction to the IV approach. That what does its background? Where does what made us come with this IV approach exactly? What was it that we thought like not to solve through the conventional approach? Our time was one, yes, definitely, because it was taking long time to solve a particular question through a conventional approach. But again, IV, what is its meaning? And everything is something we will talk about. So conventional approach, right? Official guide, we have been dealing with official guide, everyone has it from 2020 21 is itself. So looking into those particular solutions through the OGs, what we found was, like, they're too lengthy and too conventional. So indirectly they are very much time consuming. And when it comes to the time consuming, what happens is, like, you lose your motivation, and therein where we start getting frustrated. So that was the one reason why we brought in the IV approach concept, and we have devised it solving almost 100,000 questions so that it is applicable to every sort of questions. When we talk about the conventional approach, so how the conventional approach takes a particular solution to the question. So explanation of the question, so there would be a question, then you need to convert those questions into variables. After converting the question into variables, you will set up the equations. So I mean, you have a question, then you're understanding, comprehending it, and then assigning a variable to it. After assigning the variable to it, you are setting up equations, post which you start doing your calculations. Now let me tell you guys, this calculation part also has to be taken very careful, because many a times it happens that we end up making some silly errors. So you need to be very very focused on that. And post calculations, therein where we mark the answers. So I would say these are the all in total 5 steps that is required, which has been there into, I would say it's an outline of the conventional approach. In short, you go for explanation of the question. That is something which you have to do because you have to comprehend it. Then you convert the question into variables. If the variables are hidden, then you find those new, you assign, you set up the equations, you do the calculations, and you get the answer. So there are 5 steps involved. These are the major steps, all the sub steps that are involved within it, because that calculation itself is not just one step. It may have 4 steps into it, so you could see how lengthy this particular solution could be. But when we talk about the axiom that I would be discussing today, the highlight of the IV approach, because IV approach is all comprises of axioms and everything. How does this 5 steps get reduced is what the major way. So explanation of the question is definitely has to be done, so no one can run through it. You cannot just get escape, uh, unless it is a question that you have solved many a times and your luck goes good and it's there on your screen. But that is one out of, I would say, 1,000 or 10,000. That is the probability. So you need to comprehend the question, and now without putting yourself into variable, you have to directly set up the equation. So now we have already trespassed that variable step into it. And then we start doing the calculation to get the answer. So it has already reduced its pathway to from 5 to 4 steps. Having said that, if we go ahead with this, then we have already lessened the number of steps that is required into this. So it explains the explanation, the question. So, explanation, it's done by you. You set up the equations directly because you have the concepts ready with you. And start doing the calculations, perform some operations. Once done, mark your answer. That is it. So if I would say, let's go ahead with it and talk about this. Now you need to be real focused. Keep your pen paper ready. And if you have anything, just put your thoughts into the chat window. I would be definitely looking at the chat window. And yes, that is it. And if you have to connect with me directly, I've already told you, you can talk to me, just putting up an appointment scheduling. The links are on www.mathrevolution.com. It's also there on gmatclub.com as well. Right. So this webinar is all about tips and techniques because that is what everyone is looking forward to. Everyone knows math, so it's not a difficult part. It's all about the application. There has to be some shortcuts. There has to be some tips and techniques to save time, to mark accurate, and to score Q51. That is it. So let's go ahead with our journey today. Let's understand the basic concepts of IV approach. What does PS question means and how do we solve? So now you will be start looking out something very important, and you can make a note of it into your paper or copy. So PS question is all about setting up equations that we have talked about. You need to solve questions. Minimize the step errors. So because if you involve more steps, the chances of you making an error into those steps are increased. So if you have less number of steps, therein where you could reduce the errors. And the major errors are step errors and the decimal errors that we will talk about, because decimals are very freaky and it's at times it becomes very difficult to manage. If you have a percent question, then we have a 100 multiplication method. That's one of the axiom that we are about to discuss in forthcoming slides. If you have a fraction question, then we talk about the LCM method, that is least common multiple method. How do we apply it? Is something we're gonna see in a short while from now. And let's go ahead with this. EET is it's one of the major concept. Mixtures questions are very hard to tackle, and weighted average is hard to tackle at times. So EET is one thing that can help us in that particular way. So let's go ahead with this. The percent and the least common method. I'm talking about percent and the least common multiple method first. So if you want to make a note of it, it's the percentages and it's a LCM method. So when we deal with the term percentages, it's pretty visible because they have a symbol of percentage and we can easily understand. But now percentage itself is not a topic, but it's an application. You may have a question based on simple and compound interest. You may have a question on set. You may have questions on standard deviation. You may have questions into integers, and there are a lot of ways therein where percentage plays an important role. They may ask you reverse percentages, they may ask you successive discounts, profit and loss. So there are a lot of ways they can frame the question to talk about the percentage. So percentage is a concept that is applied throughout a lot of topics. So whenever you see percentage, I will say just conjoin 100, just think about the initial start of 100 rather than making yourself fall for any variable like X. I mean, like we have during our high school, we have been always taught, let the number be X, let the original salary be X, let that unknown be X. That X, since my high school, is still unknown till today. So we don't want to get fall for those kind of variable, those kind of variables and the conventional approach. Let's just start our solution by just taking 100, and that is something works for us. So we are not converting the process to solve the questions into fractions or decimal. If you take X, you are likely to fall for fractions or decimal. So taking 100, it becomes much easier. And on the right hand side on the screen right now, you will see the LCM method, which is the least common multiple. So whenever we deal with fractions, we always talk about the LCM. And when we talk about the LCM, we always talk about the LCMs of denominators. This will be further explained to you in much better way. And least common multiple method is very easy. LCM is not that difficult to find through. So there are two things, two takeaways right now that we have got. First, percentage is 100, and fractions LCM method. So short, so simple. So think that approach that can give you such a short liner tips, how effective it would be when you apply it to the questions. We'll be talking more about this right now, into forthcoming. And let's talk about the 2 by 2 questions type. Now, see, 2 by 2 questions type. So there would be a dealing between the variables. Suppose I went to buy apple and oranges. Now, apple and oranges are entities. So I would have the unit price for them and I will buy them in terms of quantity. So now apple and oranges are the separated 2 by 2. They're not the complementary 2 by 2. Complementary itself says that I like music and I don't like music. So there are boys in the class who like music, there are boys in the class who do not like music. There are girls in the class who like music, there are girls in the class who do not like music. So now we are getting to know that there are two categories, out of which boys and girls, and now they have been more aligned and categorized into all those who, the boys who likes music, girls who like music, so total number of students who like music. So now, wherein you could relate the complement winner, A and not A, B and not B. So such kind of words are always related to complementary 2 by 2 table. And separated 2 by 2 tables are the entities which are related to each other, like rate, time, and work. Then we have a lot of other those. So this is how we will be talking about this application today. So the first one was percentage is 100. Second one is fractions LCM. The third one that we have just briefly talked about is complementary tables or separated 2 by 2 tables. Now, when we talk about the terms of IV approach, this is one of the major slide, I would say. One that is about to get fleshed. So if you ready with your mobile phones, you can definitely take the pictures. And I'll try my best to cover up everything, but if there is something you want to definitely discuss, please write back to us and we will be more than happy to assist you in every manner we can. So local ratio is usually dealt into conditional probability. That is one of the most important topic, and which is asked in GMAT. And also I have found, like, most of the students often struggle with this. It's not probability, it's conditional probability, exactly. So that has to be taken care of. Complementary 2 by 2 is something which is a terms. Separated 2 by 2, it's a term. Then we have a percentages questions. Then we have a fraction questions. And then, so this is what, or this is how the IV approach looks like. It will be there on your screen in the next 2 seconds, and you can take a complete picture of it. I'll hold the slide for a minute so that every one of you are able to take a hold of it. So these are the terms that I prominently used into IV approach. We talk about local ratio, which is altogether a conditional probability. We talk about complementary 2 by 2. We talk about separated 2 by 2. Percentages question is all about conjoining 100 with the initial of the related word. So if we are talking about the population, it would be P. If you're talking about boys, it will be B. Fraction questions, as I've already talked about, least common multiple. So this is one that you can definitely click right now. Now let's go ahead. There is one more, which is EET and axiom 1, 2, 3. So we'll be starting with axiom 1, 2, and 3, and then we have a more axiom to follow through. So EET is each together. So container A, container B mixed into container C, so that becomes each together. Boys, girls, and class, so that becomes each together. So solving such kind of questions is a bit tricky, may take a long time, and it will definitely take a lot of amount of time if you go through the conventional approach. Now, if you go through the PS questions, the next slide that you will have onto your screen would be all about the category of all those particular set of topics from where the PS questions are set. So yes, definitely you could take a picture of that as well. And this is something which I have also covered into my last webinar when I was talking about how should a non-math background student should tackle the GMAT quant. How should the preparation go? So this is one of the slide. PS questions are majorly from integers, statistics, inequalities, absolute value, probability, equations, sequence, function, geometry, work rate and speed rate, ratio, proportion, set, and exponent. Out of this, integers, statistics, inequalities and absolute value, probability, and geometry. If you guys can get a hold of this particular set of topics for both PS and DS, you're already at Q45. Then you just have to jump through 48 and then 250, 51. So this is how your planning should be. So this is one of the slide. Hoping the picture taking has been done by the students. Moving ahead with the same. So key questions, as I told, next, the key questions all based on integers, statistics, inequalities, absolute values, and probability. So and integers again plays they are very much finicky, to be honest. So there would be revealed integers, there would be hidden integers we need to understand. So if I say 9, it can be written as 3 squared. If we are just dealing into terms of integers, then it would be written as 3 squared. I could say 9 to the power of 1 as well. So now that 1 was hidden, so this is wherein we have to play and pay much attention to it. So that is wherein integers are dealt with the hidden integers and reveal integers. Then we have a statistics, then we have inequalities, then we have absolute values, and then we have probability. Probability is generally conditional probability in Bayes' theorem, so that is what is more work upon. Now let's talk about the 4 difficulty levels of the PS questions. And so they are easy, medium, hard, and very hard. So if you could get aligned to a particular course, maybe therein where your practice questions maybe are aligned well into those particular category, like easy, medium, hard, and very hard, you can easily track your progress, understanding that, okay, so easy and medium is something I can really do, and it becomes much easier for me. So that means I'm already at Q40. Now, if I am able to perform good with hard questions, then definitely I'm at Q45 above. If I'm not able to make out with the hard questions of any particular topic, that is wherein I have to improve and learn or relearn again. So such categorical or consolidated, resources are pretty required for any GMAT aspirant. You can see the highlight of all those onto mathrevolution.com. You can just sign up and have a look over it. It's been pretty well assigned, and that is what I'm been talking about. Speaking ahead, the type of questions, PS questions are based on arithmetic, algebra, geometry, and word problem. It's AAGW. It's arithmetic, algebra, geometry, and word problem. So there are the four types of questions that the PS deal with: arithmetic, algebra, geometry, and word problems. Now, the upcoming slide would start the IB approach application. So we'll start with the local ratios, or more prominently, the partial ratios, and that your part will becomes the whole. So if I've got 10 things, if I pick five out of it, and then out of those five, if I pick two, then 10 is out of the picture and five becomes as my whole. So, this is what we have been talking about. Right now, we see a rectangular box. We have a students two. Then we have an oval, which has got a rectangle as well, with a word physics written into it with number two. We have a glasses with number six. So the outer rectangle is all the students. The oval or the circle that we are looking at are all those students who wear glasses. So the big rectangle is all about the students, and the oval is all about those students who wear the glasses, because it's not mandatory that every student will wear the glass. An inner rectangle that right now we see into the screen are the students with glasses who study physics. So there could be students without glasses who study physics. There could be students who study physics and they wear the glasses. So this is how we have segregated it. So just remember this number 2, 6, and 2. And now let's talk about this. So outer rectangle, the total number of students that we have right now is 2 plus 6 plus 2, that becomes 10. The total students are 2 plus 6 plus 2, that becomes 10. Number of students who wear glasses are 6 plus 2, which is 8. And number of students with glasses who study physics are 2. I again repeated outer rectangle. The total students are 10, which is 2 plus 6 plus 2. Number of students who wear glasses are 6 plus 2, which is 8. And number of students with glasses who study physics are 2. Now let's think about a possible question that they can ask in this general format. So the question could be framed as: find the percentage of students studying physics to the total students. Now, when we see the word two, we know that it's a ratio, and we have to deal in terms of percentages, and it has to be find the percentages of students studying physics. The number of students who are studying physics were 2, and we are finding it to the total students, which were 20. No, they were 10. We had 2 plus 6 plus 2, so they were 10. So all in total, 2 over 10 becomes 1 over 5. Now, since I have to convert that into percentages, I'll multiply it by 100. So 1/5 of the 100 is 20%. So therein where I get my answer. But now think about the question that find the percentages of students who are studying physics to the students wearing glasses. Now they're not talking about the total students. So 10 is out of the picture. They're just talking about to find a percentage, the number of students who study physics to that out of all those students who are wearing glasses. So number of students studying physics were 2, and all the students who were wearing glasses, including studying of physics, were 8. 2 out of 8 becomes 1/4, and a quarter of 100 is 25%. So now if you can understand, the denominator has already changed from 10 to 8, which now has become whole. So this is the basic concept of a local ratio, which we called as IB approach 1, that your part becomes whole. Let's talk about the IB approach second, which is based on a complementary 2 by 2 table. The complementary 2 by 2 table, how does it look like and how do we form it? Is will be there on your screen in the next 1 second. And in that, you need to just make sure that you focus majorly upon the column and the row that has been taken. So complementary 2 by 2 table, as it look right now, it says it would have number of students who are studying math and who are not studying math. So we have got two category from the same one, math and non-math. And on the columns, we have studying physics and non-studying physics. So there could be the student who is studying math and physics both, math and not physics, not math and physics, and not math, not physics. So it is like neither math nor physics. And then we have a total. So this is how the 2 by 2 table looks like. And this is the description that I've already talked about. So the column talks about the students who take physics and the students who do not take physics or not studying physics. Rows are talking about people who are, or the students who are studying math and who do not take math. So this is a basic concept of complementary 2 by 2 table. We'll soon see the applications of all this in the questions. So just be patient, stick to your seats, and keep on noting whatever you feel is the important one. Post this particular slide, we have a question coming in, and we will be talking about that question in terms of complementary 2 by 2 table maybe. And when I say that PS is the IV approach is applicable, it doesn't restrict itself only to 600 or 500 level questions. You can even solve 700 plus level questions using an IV approach. All right, guys, let's start the journey. Let's have a quick understanding of this question, that is explanation to the question, and let's see. I would request and recommend and like if someone could, or most of you can solve this question using a complementary 2 by 2 table quick and can throw your answers onto the chat window like right now, because we are dealing with GMAT Quant, which is time bounded. So let's see how many answers I get. Meanwhile, let's start reading the question. So there are 300 employees in a certain company. 60 employees are female who are married, and 105 employees are single males. So right now they are talking about company, females and males. Female with a condition that they're married, males with a condition that they're single. The number of employees who are married is twice as many as the number of female employees. And we need to find how many married male employees are there in the company. So male and female are complementary words to each other. Single and married are again a complementary words to each other. So I understand that this particular question would require a complementary 2 by 2 table for sure. We need to find the number of married male employees in the company. We'll divide the particular table into complementary males and females, married and single. So this are so now see understand there are sometimes hidden 2 by 2 tables as well. We need to understand because it's been framed in such a way that we have to understand whether they make a complementary pair or not. So just don't pass through the question getting to know that they will always give you such complementary words which you could relate. There are many instances therein where they have given words which has to be revealed as complementary. And let's talk about the information that we get from the question. We have total employees as 300. We have a married females as 60. We have 105 single males. This is how my complementary table would look. I'll assign the numbers. Let the married males be B and let the single females be A. So I have a married females as 60. I have a single females as A. So my total females happen to be 60 plus A. I have males as B, and I have single males as 105. So my total males become 105 plus B. Total married happens to be 60 plus B, which include females and males both. Total singles are A plus 105, which happens to be the all total single people in the company, and overall total becomes 165 plus A plus B. Now we have been all given a question, a condition here. The number of employees who are married is twice as many as. Now over here, we have an IV approach axiom 3. X is something as Y, or something as Y as X. So in that scenario, if you feel that you have a trouble equating it, it is always X equals to something Y. So this is one of the most important axiom that we are applying here. So 60 plus B, the number of employees who are married, which is 60 plus B, is twice as many. That becomes something. So that something is twice. So A is equals to 2 times of number of female employees, which were A plus 60. So X is as Y, or X is something as Y. So X equals to that something times Y. Over here, X is 60 plus B. Over here, that something is twice. The Y is A plus 60. I've started receiving the answers as D, and that is good. So let's simplify this. 60 plus B happens to be 2A plus 60. Rearranging gets me B is equals to 2A plus 60. Total employees were 300. So 165 plus A plus B is 300. So we can definitely find the value of B here, which is 300 minus 165 minus A. So we can equate it in terms of B, which is 135 minus A. We have got two equations for B. One is 2A plus 60, another is 135 minus A. We can certainly equate them, putting them equals to each other, and we could get the value of A equals to 25. Having got A equals to 25, substitute that value of A into either of the equations, which is 135 minus A. 135 minus 25 gives me B equals to 110. So the initial part of this question was a comprehension and quickly form the or draw out the complementary table. Once that is done, the major focus was to be paid on the line that say the number of employees who are married is twice as many as number of female employees. So a person who is able to crack this is able to convert that into an algebraic equation as done with this particular question, because the later half of the question just involved rearranging a simple substitution and simplification. So our answer goes as 110. So kudos for all those who have got the answers as D. Shashank and Deepak have already got the answers as D. Good job. Let's move ahead with the next approach. So as we have already gone through complementary 2 by 2 table, it's much better to take separated 2 by 2 table to understand that how different it look likes as compared to complementary 2 by 2. I already took that particular example of apples and oranges. So I had to go and buy an apple or oranges. So they are a complement. They cannot be a complementary pair. They are the unique entities. So I'll be buying a quantity of apples with its unit price associated. I'll be buying oranges at its for a particular quantity of oranges at its unit price. So the table that looks like to us, the separated 2 by table, is this. So apples, oranges, and total, and we have a quantity, we have a unit price. A basic description is there. So columns have a different product, rows have a quantity and unit price. And let's talk about one of the questions based on the same. On separated 2 by table, keep your pen paper ready. And let's see who all gets the correct answer for the next question, which is about to be there on your screen. So, just don't rush whenever you read the question. So the basic format, the best way to solve any GMAT quant questions is very simple. It's a very simple formula to be very much, applied. Read the question, very slow, don't rush, collect all the information, keep writing all the information that you get through while reading. And then you would be able to get to know what all data you have collected or information you have, what the question is asking, and how could you relate the asked question to the data that you already have. Do you still have to find something else, or you have plentiful information to answer the question? Now this is wherein a student gets trapped. They start calculating, over assuming questions. They end up doing unwanted solutions. Their answer is okay. I won't say their answer never comes accurate. They would get answers with accuracy, but the time that they consume in solving a particular question would be so long that then they actually struggle at the end. And the common comments that comes through the students are, we have been facing a situation there in where we have just got 10 minutes at the end, and we just have 10 questions remaining. All right, so let's do quickly this question. Publisher X sells books through its physical orders or mobile app. It currently has a promotion that offers a 20% discount if book B, which was published last Monday, is sold through a mobile app. Questions which are too much wordy. Just look if you have some non-essential clauses which you don't want to read, because you guys all have been preparing for verbal, so you do understand those clauses, where to read and where to leave them. If book B is sold at the stores, publisher X offers no discount. Last week, it sold 150 books through both the stores and the mobile app. So, what I could understand so far right now, that publisher X has got two modes of selling the books, either through a physical store or through a mobile app. Now, see, this particular case, if we have to say store and mobile app, they cannot be complementary. So we understand now there are two unique things, two different things here. So we have to relate them to a separated 2 by 2 table. So let's see what all information that we have. Let's form the separated 2 by table. So we have the books which are sold at stores. We'll assign them as A. We have books quantity which are sold at mobile app, through the mobile app. So we have assumed them to be B. Last week it sold 150 book through both the stores and mobile apps. So total A plus B becomes 150. That is the information that we have got from the question. Unit selling price for selling at the store is $10 per copy. That's the original price of the book. And price at the store is $10, and price through the mobile app. So if he says over here, it currently has a promotion that offers a 20% discount if book B is sold through a mobile app. So 20% discount, that means he's still charging the 80% of 10, which is $8. So if he's selling through a mobile app, he'll charge $8. So the total value that you get, so one chocolate, if it costs $10, for two you would pay 20. That means you're multiplying, you're not adding it. So a quantity gets multiplied to unit selling price, therein where you pay. So your A times 10 becomes 10 A dollars, and B times 8 becomes 8 B dollars. And over here it says in the last line of the question that publisher X had total sales of $1,300. That's the total sales that he has made. That means 10A plus 8B is equals to 1,300. I've read through the questions and I started marking my table. It's not that I've read the complete question and then I'm starting again to make my table and go back to the question to just re-verify and recheck what the information was given. So whatever you read, just start jotting down so that your table is automatically completed. We have all the data here. Now what we are left is simple substitutions or simple arrangements and rearranging. We have A plus B equals to 150. So we can get a value of A. If we substitute that value of A into the final equation, that is 10A plus 8B equals to 1,300, we'll get the value of B. Once we get the value of B, that is what we have been looking for. How many books did it sell through the mobile app? So the equation that we have is 10A plus 8B equals to 1,300. It's a linear equation in two variables. If I could substitute the value of A in terms of B or B in terms of A, I could really get those values. So that should not be a real hassle for any GMAT aspirant, because that's one of the very basic that you could solve through. So the final answers goes as 100E. Very happy to see you guys getting the right answers. Shashank, Deepak, Finn, good job, great. But I still request to apply the the IV approaches, please, and because that is the worth of the webinar, and that is the importance of today's webinar. I agree and respect what you know, what approaches you know, they're good, but try applying what we are learning today. Yes, Shashank, it's a Calendly appointment that students book to talk to me. And Math Revolution always sends the links for its own webinar to their students. Okay, let's talk about the LCM and fractions. One of the most important approach that I will be talking about, the LCM and fractions. So whenever we deal with the fraction, question has a fraction, just attach the LCM of denominator. 1, 4 and 1, 3. 1 over 4 and 1 over 3. 12. That is it. I'm not dealing with x and then x over 4 and x minus x over 4 making it 3x over 4 and then one third of it making it 3x over 12. I started my question with x. I'm still getting 2x at the end. I'm still at x itself at the end. The only thing is that x looks much different to me. It may be like 7x over 9 now, but it is still x. If you start with a variable, you are always ending with a variable, and then you're equating it to something to find the answer. That is what a conventional approach is all about. Let's overcome it. Let's talk about how do we talk and try to do the LCMs and the fraction questions. So we would be attaching the least common multiple, the LCM of the denominator. So let's pay attention to one of the question coming on to the next slide, in which we'll be able to see the fractions, and then we'll be applying the IV approach 3-1, which is LCM and fractions, attaching the denominator to the initial word. So question says, when 40 gallons of oil are added to a tank, the amount of oil in the tank increases from two-thirds of its capacity to 5/6 of the maximum capacity. Now, we are not aware about what the maximum capacity is all about. We are not aware about what is it exactly. So in that scenario, what we know is when 40 gallons of oil is added, the amount of oil in the tank will increase from two-thirds of its maximum capacity to 5/6. Now, the question is still asking what is the maximum capacity of the tank. Now I could see there are two fractions, 2 over 3 and 5 over 6. Simple, I'll attach the LCM, the denominators of fraction. So this, we are talking in terms of capacity. We need to find the maximum capacity. We take an initial of capacity as C. Let's just focus on the denominators of both the fractions, which is 3 and 6. The LCM goes as 6. My complete maximum capacity becomes 6C. Now out of this 6C, C is the initial of word capacity. 6 is the LCM of the denominators. Where it says two-thirds of its maximum capacity, that means 2 over 3 times of 6C. Now think about, if I ask you 2 over 3 times of y is how much? You will say 2y over 3. So your y is still there. I'm giving you y, and y is still there. But if I say two-thirds of 6C, that means you could directly answer that becomes 4C. And 5/6 of the maximum capacity, that becomes 5C. So now the question says, then when you add 40 gallons of the oil, there is an increase from two-thirds to 5/6. So increase is of C for every 40 gallons that is added. So maximum capacity would be 6 times 40, which is 240. Simple. So whenever you attach such sort of LCMs, your job is done. Good job, Shashank, Rohit, Deepak, and Sukanya. You already got there. Shashank, these all questions are from the GMAT somewhere, because they have been there into GMAT. And to show the applications of all the IV approach. So see, the webinar is not about, to test the students. You guys are already good at it, so you know how to solve. It was all about to show how the IV approach is applied to these questions. So you may relatively find them easy, maybe, but anything that is easy for you may not be easy for someone else. So, we need to just deal with this. So A is the correct answer. Let's go with 100 and percent, which is IV approach 3, 2. So if you're dealing with the percentages, we need to attach 100 to the related initial letters. So that was, if you remember, when we started when I started with talking about the IV approaches, it was all about the percentages. I said conjoin 100. So this is the approach that is coming through. If your question has fraction, you attach LCM of the denominators. If your question has percentages, you attach 100 to the initial letter. Let's talk about the question here. On the next slide, you will get a question. I'll give you 3 seconds to solve that question if you could. Just 3 seconds to solve that question. I'll hold the slide and you'll have 3 seconds to solve that particular question. So keep ready. It's about to get fleshed. Your time is on. I'm giving you 3 more seconds. People, I'm looking for the answers. Meanwhile, I'll just read the question for the audience. If John gives 20% of his prize money to his mother, 60% of the remaining prize money to his father, and the rest of his to son, what fraction of the total prize money would he give to his son? Deepak has got the answer. Okay. If I take X, I'm gone. So I'll not go for it. I'll simply apply the IV approach for 100. Now, this is something axiom 1 that I have been talking since the start. Okay, we have a mix up of answers. Rohit says A, Deepak says D, Tushar is D. Okay, guys, I respect your way to solve. Now, just pay attention to this one thing. There's an axiom 1 that I have been talking about in this particular question, which says, I'll go a bit slow on this. So it says, like, if you have a word like what fraction, what number, how many times. So that is all about something or a theta maybe, or you can, you can symbolize it with anything. The word of is all about the multiplication. Is equals to, so is, was, were, has, will be is all equal to, and percentage we know is 1 over 100. Why am I talking this is 2 is what percent of 50 and 2% of 50 is two different things. 2 is what percent of 50 and 2% of 50 is different things. So if anyone who struggles to form that algebraic expression, this is the axiom that will help. All right, so we have got answers from all. Let's not delay and let's have the curtains off from the solution. We need to find what the fraction of total prize money that John has given to his son. We assume the John total prize money to be 100p because p is the initials for price. Percentage question, we have attached it to 100. P is the initials of price, yes. When he gives 20%, so 20% of 100 would be 20. So he's already given 20p. That means he would be left with 100p minus 20p, that becomes 80p. Out of this 80p, 60% has been given to father. 60% of 80p would be 48. So now 48p, now this is a concept of the local ratio. Earlier it was 100, out of which 20% was given, that means 20 was given, 80 is remaining. Now this 80 has become the whole. So this is a local ratio application. It's a part becomes the whole. So out of 80, the calculation begins now. So out of 80, 60% was given. That means 48p was given. So we have been left with 80 minus 48, which is 32p. Now this is given to whom? So this is how the application of axiom 1 looks like to us. What fraction of the total prize money would he give to his son? Let's convert this into equation. So what stands for a symbol theta? Fraction is all about multiply. Of is multiply. So fraction, what fraction is theta? Of is multiply. Total prize money was 100. Would he give? So that becomes equal to, and his son. To his son, he will give 32p. But we need to find the fraction out of total. So theta becomes 32p over 100. P gets cancelled, we get 32 over 100. It is a fraction that can still be simplified to get the answer as 8 over 25. So Deepak, Rohit, Tushar, Sukanya, Arpit, and Shruti all are correct. So the final answer goes as 8 over 25. D is the correct answer. Now let's talk about the axiom 1, which we have recently applied. It's very basic, but most important and useful. And you know what? The beauty of IV approach, I tell you, because when I talk about variable approach, I always ask my students and everyone to go very slow while learning the variable approach, because it has got some exceptions too. So that has to be mastered if you want to quickly answer the most possible answers and mark it. Like the way I mark looking at the question, that answer would be C. So I don't fall for, checking out A and B. But when it comes to PS, you can master it in within hours. I'm not talking even days, within hours, and you can apply it. So this axiom 1 right now, which we see, what fraction, this is something which we have recently applied in the last question. So if you have that particular, a portion of a struggle, therein where you often make mistakes or get confused in equating the error, just read the axiom 1. It's in lesson E and F onto mathrevolution.com also. So you can directly go ahead, sign up yourself, and use those resources for free. All those lessons. E is the lesson letter E, and F, that is all about the IV approach. And there are a lot of questions into it. I've picked a few for the webinar, but there are a lot of questions. So you could start applying those particular, and so learn how it is applied, then apply in the second question, so you'll make 50-50 out of it. Then in the third question, you're already on the 75% correctness and 25% confusion. From the fourth, fifth, and sixth question, you will be 100% applicant of IV approach. So in that scenario, what happens, it just took 5 questions for you to start applying the IV approach. So this is wherein you have started saving time since you have started learning it. So I'm throwing a very simple question for everyone, but the time that I'll give to you would be just 2 seconds. It would be there on your screen in next 1 second or maybe 2 seconds. So two is, this is, just be ready. I'll give you just 2 seconds to solve that question. 2 is what percent of 4? First second gone. Okay, Himanshu has already answered. Perfect. Perfect. Now see, this is what it happens, guys. When you are pushed, you would be able to do it in 2 seconds. So you should not at all talk about you take a time to solve a question. See, never ever say that the question was easy and we were able to make it. No, there would be a student maybe who would find this question also difficult. So feel proud that you are able to solve that question in 2 seconds. That means you know it how to solve it. Feel proud about it rather than quoting that was an easy question, so I was able to do it. No, you have learned it. It's your hard work, it's your smart work that you have put into over the period of months. Therefore, you're able to solve that question. Okay, going ahead with this, it's axiom 1 base. 2 is what percent of 4? So we need to talk 2 is what percent. So 2 equals to theta 1 over 100 times 4. That becomes 50. It's a, see, so this is why the reason behind putting this particular question was just to tell you that never ever say that, the question was easy and I was able to manage it. No, you know it, and this is why the question became itself easy. So, in another word, none of the question for you would be difficult. So just be focused, don't rush. It's very easy to, it's not that difficult to crack the quant. Okay, let's go ahead with the EET together, because that is one of the crucial concept. So we'll go a bit slow on that, and on the question part, we would definitely be again have a race. So EET, that means each together. So you will have something as one of the entities and something as another entity, and then you would mix up to form it as a together. More or less questions, you know, get into a line of mixtures. So therein where we'll see how does each together works. I'll throw the questions like, so we have a female students who are 14 numbers, and wearing glasses out of them four. So we have four female students who are wearing the glasses, and total female students are 4040. So the number of female students who wear glasses would be 10%. 4 out of 40 is equals to 10%. Then we have a male students who are 10 in numbers in total, and they're wearing the glasses. So two male students are wearing the glasses out of 10, so that becomes 20%. Now, when I say total, it cannot be 30%. And trust me, guys, I have actually noticed students making this error. And I would say good students. I mean, they are capable of solving Q51 level question also, but don't know what made them write that 30%. Maybe they have rushed about it, they have over assumed. It could be done, it could happen with anyone. So, every question is unique. This is what I would like to say. So together it becomes total would be 50. Out of which six students are wearing the glasses, which is 12% of the total. So this is how we solve the each together. Much easier question. Finn, this would be all. This video would be uploaded, so you could always revisit it any moment of time. All right, let's talk about the application. Let's see one more example. So we have a coffee which costs $20 per liter. Then we have milk, which costs $30 per liter. And when we mix up the whole amount of coffee and milk, we get $50. So we get 50 liters of latte. It could be cappuccino as well. It could be Nescafe. It could be espresso. It could be anything. So we are not focusing majorly on the coffee right now, but we're majorly focusing what are the mixing. So the whole amount of coffee and milk are mixed, which is 50 liters of latte. That's a $24 per liter. So in the final mixture, so we have a coffee C, we have a milk M. So $20 per liter. So 20C, that is one thing, and 30M is another thing. Becomes $24 of C plus M. And now we could definitely put in the equation to, put the values to solve this particular question. The major part was 20C, 30M, and that is equals to 24 times of C plus M. And C plus M is already 50 liters. So definitely we can solve this question for M. That will not be a big deal. Now I'll be taking a questions based on mix up concept. So it will have a percentages, it will have the ratios, it will have fractions in together. Then we have to apply the axioms. Then it will be complementary 2 by 2. So it's all a one question mix of almost everything maybe. So let's go ahead and talk about those pretty questions. So the case one right now, it says local ratio, axiom 1, and complementary 2 by 2. So we are dealing with complementary table. I'm not sure that whether this table would be a hidden or revealed. I mean, the words would be complementary visible, or we need to, comprehend. I would say we need to infer or deduce that from the question. So just be ready with your pen and paper. 10% of total students wear glasses and attend math class. If 60% of a student with glasses do not attend math class, they say do not attend and my job is done. They have revealed it's a complementary 2 by 2 table, but it's in percentages. What percent of the total student wear glasses? So we'll apply the IV approach, everything that we have learned. Since it's a percentage question, we are applying 100. We'll be attaching 100 to the initial letter. Second, what percent of the total student wear glass? If there happens to be a local ratio, the part becomes the whole. And third, what percent of the total student? That's the Axiom 1 application. So we need to be very much aware about what is what, how do we write off, what is percentages. So let's draw the complementary 2 by 2 table into it when we know that, there is a word called do not and attend. So percentages question, initial of students, we are talking about students. So let's take it as S. So we have the total student as 100S. Now the total students are 100S. Total students who wear glass and attend math class are 10%. So that becomes 10S. A student with glasses who do not attend math class are 60%. So that's a local ratio again, excess. Now pay attention to this. 60% of the student with glasses do not attend math class. It's not out of 100. This 60% of the students who wear glasses, they do not attend math class. So they are from the glasses group. So it's a part of the whole. So this is the catch in this particular question. The 60% are not from 100. So if I take that local ratio is XS, S is the initial of a student, and we can say that local ratio was X, that those X are 60%. So if those X's are 60%, 10S will automatically become 40%. Because read this, a student with glasses do not attend math class. A student wear glasses and attend math class at 10%. So this 60%, they do not attend math class, they are wearing glasses, are 60%. So people or the students who attend math class and wearing glasses would be 40%. And this X plus 10 makes it 100%. Himanshu has already got the answer. Okay. So this is how the complementary table look like to us. We have a math class, we have no math class, we have glasses, we have no glasses. We got the values for math class and no math class. We got the values for total. Total what 100 students already. So students wearing glasses are 40 over 100. That is equal to 10s. A student wearing glasses are 10s times 100 over 40. That becomes 25s. So 40% of students wearing glass is equals to 10s. So student wearing glass are automatically 25. So we need to find what percent of total students put on glasses. What is theta? Percent is 1 over 100. Off is multiply. Total students are 100s. Put on the glasses equals to 25s. We need to find the value of theta. 100 gets cancelled out. We're left with 25%. The answer goes as C. Okay, let's go on to the case number 2. In this, we'll be dealing with LCM. We have a fractions as well, and we have a local ratios. So the question would be talking about a lot of values, and then it will be talking about a lot of fractions. So the only thing which you have to pay attention to is if there is a fraction, as many as fractions are there, take the LCM of all the denominators available, attach to the initial letters, and then the job is done. So the question here says John invested 1 over 2 of his total assets into X and invested one third of the remaining assets into Y. After that, he invested 3 over 4 of the remaining assets into Z. So there are three investments made, one in X, one in Y, one in Z. The fractions are different, and for Y and Z are the remaining portions. If the final remaining assets after three investments were $1,000, need to find the original value. Without delay, let's apply the IV approach. We know LCM and fractions, we need to attach the LCM of denominators, and definitely the part becomes whole. Question is, find the value of original assets if the final remaining assets were $1,000. So for percentage question, we always use 100. For fractions, we always use LCM. We have three fractions, 1 over 2, 1 over 3, 3 over 4. Let's take the LCM of 2, 3, 4, which happens to be 12. We are dealing with the word asset. Let's attach an initial letter A to it. So total assets become 12A. Now let's talk about the fractions. John invested half of his total assets into X. Half of 12A becomes 6A. Remaining are 6A. Out of this 6A, one third was in Y. So one third of 6A becomes 2A. Remaining are 4A. Out of this 4A, 3/4 of the remaining assets are for Z. So Z becomes 3A because that is 3 over 4 times of 4A. So you're left out with A. If the final remaining assets after three investment were 1,000, what was the original? Your final is 1,000. That means your A is 1,000. Your initial asset was 12A. You got the value of A is 1,000. 12 times 1,000 makes it 12,000. Answer goes as C. Your job is done. We mark the answer as C. Let's go on to the next question, which will have 100 percentage local ratios and axiom 1 application. Just pay attention if there happens to be the need of complementary or maybe a separated 2 by 2 table, because many times it is not that much revealed. So we need to infer and deduce it. So the question on the screen right now talks about John. So he cleaned the windows in his house. After breakfast, John cleaned 20% of all windows. After lunch, he cleaned 30% of the remaining windows. And afterward, John cleaned 50% of final remaining windows. What percent of the total number of windows were not cleaned? What percent of the total number? That's axiom 1. We are dealing with the percentages, so we need to talk about 100, and there would be a local ratio. So let's apply the IV approach. We're talking about the windows, which is W. Number would be 100. So the first slide right now would be pretty inferred. It will have IV approach 3, 2, which is 100 and a percent. It will have a local ratio application. It will have an axiom 1 application, which deals with the words what, fraction, of, multiply is equals to and percentage 1 over 100. Question is asking about the percentage of total number of windows that were not cleaned. We are using the initial of the windows as W. So that becomes the total becomes 100W. For fractions, we should have found the LCM. We know that. After breakfast, 20% of all the windows are done. That means 20 windows were done out of 100, 80 are remaining. Post lunch, 30% are done. Now see, 30% of 80W, again, it's a local ratio. It's part as a whole. We are not dealing with 100 now. We are dealing with 80s, out of which 30% are done. That means 24 windows are done. So we are left out with 56 windows. Out of this 56 windows, only the 50% of done. He has not completed his job. So 50% of 56, that's a half of anything, becomes 28 windows were done. That means 28 windows are not done. So 28 windows out of 100 windows, that means it's 28%. If we convert that into, yes, Himanshu, Rohit, and Deepak, you've got your answers correct. So if you apply the axiom 1, we have theta times of 1 over 100 into 100 windows. That equals to 28 windows. 100 cancels out each other. The letter W cancels out each other from both the sides, and we are left with theta is equals to 28%, which is B. Now let's quickly talk about an basic application of axiom 1. We have a question right now that we'll be talking about the percentages expressions, and this is a common question that has been seen into GMAT many a times. So it will be there on your screen soon. It's based on axiom 1 application. So if x is m% of y and z is k% of y, so x and z both are certain percentages of y, where m k product of m k is not equals to 0, we need to find x is what percent of z in terms of m and k. So it's a pretty simple algebraic expression solution. We know it's axiom 1 because it's talking about what percent, what fraction. So let's talk about, we need to find x is what percent of z, and the answer has to be in terms of m and k. So let's talk about the first part. X is m% of y. X equals to m times 1 over 100 times y. Z is, so z equals to k%, so k times 1 over 100 of, that is multiplied times y. Now when we need to find x is what percent, so that means x is equals to theta times 1 over 100 times z. You can easily substitute the value of x and z. 1 over 100 would get cancelled, y gets cancelled. The final answer becomes 100m over k. Yes, Deepak. Yes, Shashank. Yes, Sukanya. So that becomes 100m over k. So see, the basic part was the axiom 1 application. If you're good into it, your job is done. So it becomes very easy, but just don't rush many a time, because x is what percent and x% of z. So, when you rush, you majorly end up reading the question incomplete, and that is what it makes mistake. Yes, Aparna, your answer is correct. So, go slow. Even if it is a easy question, don't get overexcited. Please don't get overexcited. Just be neutral to anything. And also for a difficult, see, there's nothing called difficult. I won't say there is anything called difficult. So if there happens to be a topic coming in, suppose a probability has been flashed onto my screen right now as a question, and I'm the one who is scared of probability. Why do you have to scared about? Can you go out of your GMAT room and ask them to change the question for you? No. Can someone come to your desk to help you out in that particular moment? No. So it's you who has to deal with it. Be neutral and just solve it. I'm telling it to you, it will be automatically solved. But when you panic, oh my God, it's a probability. You have already lost 50%. So don't get overexcited and don't get panic, or don't demotivate yourself. So let's talk about the next part. 2 by 2 tables. Let's apply the 2 by 2 tables. I believe we have like 2 or 3 more questions there, and then we're done for the day. So we'll go quick on this. We have this question that will be coming for 2 by 2 table maybe. So it says like 60% in a class are female students, 25% of the male students, So yeah, if they're talking about male and female, they're talking in terms of percentages, they're talking in terms of male female. So 60% in class are female students, 25% of the male students, and 75% of female students have voted for Tom. So there are people who have not voted. Two words: voted, not voted. Two entities, male and female, complementary to each other. Let's not waste much of the time in this. Let's apply the IV approach. We know 100 because the percentages. We know part becomes the whole. We know the IV approach, Axiom 1, all about how to write what, how to write is, how to write off. So that is basic that we all know. So let's apply. For the students, we have taken the initials as S. Total student are 100 S. Female students are 60%, 60% of 100, 60 S. 100 minus 60 would be 40. Those are the male students. Male students who have voted for Tom are 25%. Female students are 75% who have voted for Tom. So those are the females out of females. So now we need to be very much sure about that 75% is being taken for 60, not 100. So that becomes a part as a whole. So we have got 25% of 40. We have got 75% of 60, which becomes 55s. So the number of students all in total who have voted for Tom are 55s out of 100. For this question, I could say, even if you don't want to draw a complementary 2 by 2 table, that is also okay because there is no information given for did not vote. But if there would have been a case that one of the information was talking about did not vote, and it was more or less not direct but out of a whole as a local ratio, then we would have definitely thought of making the complementary 2 by 2 table. So even if you make it, it's good. Even if you don't, that is pretty okay with this question. We have already got the answer, the 55%. Yes, Apurna. Yes, Sukanya. So 55% is the answer for this particular question. Let's talk a question about each, and together. The each, and together. Now this time it would be a mixture question for you. All these questions have been taken from the level 650 or plus. Okay, the question say the multi-grain mixture X is mixed with 50% barley and 50% rice. Just excuse me, guys. Okay, the other multi-grain mixture Y is mixed with 35% of the barley and 65% rice. If the combined mixture of X and Y includes 40% barley, what percent of the combined mixtures of X and Y is the mixture? It's all each, and together. There is a X, there is a Y, then there is a barley, there is a rice, there is a percentages. Let's talk about one of the each together example that we have done. I'll go a quick fast on it because we have already done this example. So female students 40, we had a wear out of 4. Female students were 10. Male students were 10, out of which 2 students who are wearing the glasses. That becomes 2 over 10, that is 20%. So together it becomes 50. 6 over 50, that becomes 12%. Each together, we can often draw such kind of relations. Now, this particular example has nothing to do with barley, so don't get confused. This was just an example to show how do we apply the each together. So now let's go and talk about the mixture question. We're dealing with percentages. Take the number 100. Mixture x as a small x. Mixture y as a small y. So we have 100x and 100y for both. Let's talk about each now. Mixture x, which is barley in mixture, is 50%. That becomes 50x. Barley in mixture y is 35%. So that becomes 35y. Pay attention, 100x and 100y has been assigned to both x and y. Barley is 50% in x, becomes 50x. Barley is 35% in y, becomes 35y. Total mixture becomes 100 times of x plus y. Now barley is 40% in the total mixture. So that becomes 40% of 100 of x plus y. So this is how the equation would look like to us. 50x, that is in mixture x, barley, plus 30y, which is in mixture y, is equals to 40 times of x plus y. If you could rearrange, we can definitely find the value of x and y in each other's term. So this becomes 10x equals to 5y, or 2 times of x is equals to y. We need to find what percent of the combined mixture of x and y is the mixture x. So the combined mixture was 100 of x plus y. So we know y equals to 2x, so it becomes 100x over 3x. 100 over 3 is 33.3%. Answer goes as B. Yes, guys, the answers are correct. Yes, so that was the one of the question that have been put into the last slide. And to briefly taking 5 more precious minutes of yours, I'll be talking about the math revolution. Like we have established in South Korea in the year 2001, and it's been like the site visits that happens to our website right now from all the aspirants across the globe. It's like from more than 190 countries, and we have members for more than 130 plus countries. We have catered almost 41,000 students now, and 90% of those have scored 49 out of 51. We have launched the Math Revolution global website, which is www.mathrevolution.com, in the October 2015. And the goal of the math of every single aspirant is 49, 50, 51. I know how a student gets frustrated when they have been consistently hitting 48, 48, 48, and they have finding no single way to get to 50, 51. So I understand how frustrated is that. So GMAT math is score 50, 51. Simple job. For DS questions, variable approach. For PS questions, IV approach. So I'll just brief about, I'll introduce the person who's behind this master approaches, the Max Lee, who is the founder and the CEO of, Math Revolution. He has attempted GMAT. He has taken GMAT indeed for 27 times, and for as many as times with a Q perfect score, has solved 100,000 questions to devise this particular approaches. The world's first variable approach based on logic, pattern, and orientation. And the characteristics of the math revolution approaches are simple: uniqueness, because they're world's first IV and variable approach; math skills, even if you're not from a math background, you can easily conquer this and easily master it. But as I said, DS takes time, variable approach takes time. So you need to be, consistently, learning those. Quickness, yes, definitely. You could understand how quick we were today solving the questions. See, don't talk about me because I was explaining it to all. So I was definitely taking in time to apply every single thing and equating it. But when it comes to solving, you guys can understand 2 seconds were more than enough to solve certain questions. And accuracy, of course, we're getting the right answer, so that maintains our accuracy. So the niche of the strategy for 50-51, I mean, like, see, if you're following a conventional approach, if someone is following a conventional approach and I've got good math skills, I don't disagree with the fact that she cannot score a 50-51. But the percentage amount, I mean, the number of those students out of a whole would be very less. So how to increase those percentages wherein, most of the students are able to score 50-51? It's a variable approach, DS. It's the IV approach for PS. Once your logics are done, they're intact, your confidence is boosted up, most of you would get 50-51. So that's not a very difficult task to perform. I would definitely, wait for your thought. You could write into the comments. You could definitely write us into the email that how the math revolution approach is different and better than conventional approach. And you can often leave your comment here right now. You can tap on the like button. You can tap on the dislike button depending upon your choice. But I would really wait if someone could write for us that how the math revolution approach, especially the IV and the variable, is making a way, because I've been getting continuous email about they being good. So I'll be waiting from you guys as well. And I would say just register on Math Revolution for free resources. You won't give up math, that is for sure. If you want to reach out directly to me, you can write on the email my name, that's PUNIT Puneet at mathrevolution.com. For any other inquiries, you can directly write to the team at info@mathrevolution.com. Hoping the same. Thank you so much for your patience and time. Keep preparing up, keep geared up, and just remember that no question is difficult. And just prepare and be motivated, right? Thank you so much for your time and patience. Stay blessed and have a great weekend ahead. Thank you and bye bye.